In this video, I'll give a demonstration of a vintage Admiral television set which I recently restored. I'll show a demonstration of it operating, tell you a bit about the features of this model, take a look inside, and discuss the restoration work done to it. Early experimental versions of television date back to the 1920s. But commercial television was introduced in North America in 1948. Early televisions used vacuum tubes, supported 12 VHF channels, and were black and white. Later, additional UHF channels 13 through 83 were added, and in the early 1960s, color was introduced, using a system that was backwards compatible with black and white. Also by the 1960s, sets moved to solid-state designs with transistors replacing tubes, other than the picture tube. Analog television broadcasting was mostly phased out in 2009 in the US and 2011 in Canada in favor of digital television. The impact of this is that analog televisions like this one can no longer receive over-the-air signals without an adapter. However, they continue to work with devices like VCRs and DVD players that have NTSC video out, provided that they have an RF output or an RF modulator is used. In case you're interested in working on an old set like this one, let me say a few words about safety. Like old vacuum tube radios, there are hazardous voltages present which can be lethal, so you need to use caution when working on the circuits. Also, like old radios, some don't use a power transformer and may have AC line voltage present on the chassis. The power supply capacitors can hold a charge for a period of time even when the unit is unplugged, so they should be discharged before working on it. Unlike radios, televisions generate extremely high voltages to drive the picture tube. This unit uses about 16,000 volts, and larger televisions use higher voltages. This is extremely dangerous, and measuring these voltages requires special test equipment, which I'll demonstrate later. Keep well away from the high voltage sections. The CRT contains a capacitor which charges to the high voltage, which can also hold a charge for a period of time and should be discharged before working on the set. The picture tube is also dangerous, with the possibility of breakage and subsequent implosion that could injure you with flying glass. Early units like this one have tempered safety glass in the cabinet to protect the CRT from damage if something hits it, and protect users if the CRT implodes. When working on the chassis outside of the cabinet, the safety glass is no longer present, so handle the CRT very carefully and wear safety glasses to provide some protection. I've restored many radios and test equipment, but I wanted to restore an old television so I could learn more about this technology. This is a Canadian Admiral model T1832X television with a 20X5ZX chassis. It was made in Port Credit, Ontario, near Toronto, and is the 1955 model year, so it was probably manufactured in 1956. It's a black and white television with a 17-inch screen and receives VHF channels 2 through 13. The picture tube type is 17HP4B. It's a pretty standard design for the time and utilizes 19 vacuum tubes. The video IF frequency is 25.75 MHz and the sound IF is 21.25 MHz. It uses the so-called intercarrier IF design. The cabinet is brown bakelite with user controls on the front and additional controls on the back, which we'll cover in detail later. It has no legs, and so it would need to be placed on some type of table to watch it conveniently. There's a built-in speaker and a small built-in antenna, but it would typically use an external antenna, at minimum the rabbit ears type, to receive stations. The front panel says Advanced Cascode. The cascode is a two-stage amplifier circuit composed of a transconductance amplifier followed by a current buffer, and in this set, the circuit is used by the RF amplifier in the tuner. I bought this from a local seller on Kijiji. It took me a few years to find a suitable model that was of the right age and was local so that it did not have to be shipped to me at a high cost. As received, it was reported to be working. The seller said he had paid a local Antique Radio Club member to make some adjustments. I did a significant amount of additional work to restore it, as I'll describe later. The Bakelite case was in great condition with no visible cracks and few scratches. Let's take a look at the unit operating. I have it hooked up to a VCR which has an RF output. Through it I can also connect it to this DVD player. Front panel controls are typically known as user controls and included any controls that needed regular adjustment. The front panel controls are the following: power and volume, as well as contrast. Next is vertical hold, horizontal hold, and brightness. Finally, we have tuning with channels 2 through 13 with fine tuning on the same shaft. On the rear panel are additional service controls that typically did not need to be adjusted often, if ever, by the user. On the back we have vertical linearity, horizontal drive, and height. There's a small internal wire antenna that would only be suitable for receiving very strong local stations. To use this, you jumper it to the antenna input using the terminals on the back. I don't think the upper terminals are original. Typically the set would be used with an external antenna that would be connected to these screw terminals. Note that there's no direct video or audio inputs in sets of this vintage, so to use it with a VCR or DVD player, you need one with an RF output or to use an external RF modulator. My VCR has an RF output. My DVD player does not, but I can connect it to the VCR's input and then play it through the VCR. The line cord originally would connect here using an interlock connector that would disconnect it if the rear panel was removed, a safety feature to reduce the chances of getting a shock. This was changed by some previous owner, as I'll discuss later when I talk about the restoration. Here I'm displaying a test pattern generated from a DVD that has various television test patterns. Alignment is not great, and there are some vertical bars which may be a defect in the picture tube or deflection coils due to their age. Any flickering that you see is an artifact of the digital camera I'm using and is not actually visible on the set itself. Here we see a DVD of an old episode of the television program The Honeymooners, a popular program at the time the set was built. I've removed the chassis from the cabinet so we can take a look at it on the bench. The 17-inch CRT is held in place with a strap, springs, and a metal bracket. There's a large power transformer at the back right. This large transformer is used for the vertical deflection circuit and the smaller transformer for the audio output. The speaker connects here and is normally mounted inside the cabinet. The two metal cans are electrolytic filter capacitors. The set uses a total of 19 tubes of various types and sizes. Inside this metal box, sometimes called the doghouse, is the flyback transformer and high voltage rectifier. It's shielded for safety. The tuner is in a separate unit here and uses two tubes. Looking at the bottom of the chassis, you can see all of the wiring, which is point-to-point using tube sockets and some terminal strips. This is the power supply filter choke, and this transformer is part of the vertical oscillator circuit. The high voltage rectifier tube has a special high voltage socket which is thick plastic to avoid any high voltage arcing to nearby components or the chassis. The yellow capacitors are new ones which were replaced as part of the recapping process during restoration. The originals were wax-covered paper capacitors which are notorious for becoming electrically leaky after several decades of use. The large electrolytic capacitors also tend to fail over time and were replaced. I installed the replacements by adding some terminal strips and wired to the new caps, keeping the old ones disconnected but still installed so the chassis looks original from the top. The tuner has a cover which opens. It's a turret type where the tune circuits for each channel rotate and make connection using switch contacts. Measuring the high voltage on the picture tube requires a high voltage probe. These can be either a dedicated meter or a probe for a standard multimeter. I purchased this probe of the latter type, which connects to a multimeter and divides the voltage by a factor of 1,000. It can safely measure up to 40,000 volts DC and comes with various types of probe tips. Here I'll show measuring the voltage at the picture tube. The probe tip fits under the rubber cup of the picture tube, allowing the user to keep well away from the high voltage. The DMM reports the voltage as about 16.5 kilovolts. After disconnecting power, you can use the same probe to discharge the high voltage before working on the set. The first step was to obtain a service manual for the set. The Howard Sams Company published service manuals for all major television manufacturers. I was able to identify the manual for the US version of the Canadian-made set and ordered an original copy from a supplier on the internet. Sams is still in business and will also sell electronic download copies of their manuals. The US model was slightly different from mine. Some difference noted were, this set uses 19 rather than 20 tubes. There's one less audio amplifier stage. Mine uses a permanent magnet speaker, where the US model used a field coil which doubled as the power supply filter choke. Some versions of the US model used a printed circuit board rather than all point-to-point wiring. And there are some miscellaneous circuit changes, including one different tube type. Some models had a 21-inch screen, while others like this one were 17-inch. The Sams PhotoFact covers several models with the same series of chassis. The unit pictured has a wooden case that's tall enough to sit on the floor. Despite the differences, the manual for the US model was helpful, particularly as it had alignment and troubleshooting procedures. In all, it's 24 pages in length and quite comprehensive. Restoration started with a visual inspection. There were no obvious parts replaced over the years. It was quite dusty, especially around the high voltage areas which tend to attract dirt and dust. There was insulation flaking off of the deflection coils. I then powered the unit up slowly using a variable auto transformer or variac. As the voltage was increased, I got a raster, the white screen, and a hiss from the speaker, which looked promising. There was some arcing of high voltage inside. The chassis was then removed from the cabinet and some cleaning of the case and chassis was done. Both the picture tube and safety glass were quite dirty and cleaning them brightened up the image. I resoldered the speaker wires, which were connected using friction tape. I replaced the line cord with a new one. The old one had the interlock connector removed and it was connected using a mixture of friction or hockey tape, scotch tape, and surgical tape. I ran it through a different hole in the chassis using a rubber grommet. Hooking it up to a VCR, I was able to get a reasonably good image and sound. I did some more cleaning of the chassis. Some cracks in the flyback transformer were fixed with epoxy. No arcing was observed after this. As mentioned earlier, I replaced all the wax paper and electrolytic capacitors. After recapping, the picture quality was significantly better. When restoring electronics, I find it useful to take pictures with a digital camera before and during restoration. On one occasion during recapping, a picture helped me identify an error I had made. I also find it's useful to make notes in a notebook. I clean the controls with contact cleaner. The broken insulation on the deflection coil seemed harmless, so I simply removed any remaining loose pieces. I checked all the resistors. Most had drifted higher in value, as carbon resistors tend to do, but were still reasonably close in value. I then checked some of the key voltages against the manual. While I didn't test them, all tubes seemed to be good and none were replaced. I have a DVD of TV test patterns that I'd made some time ago. I used this to adjust vertical size and linearity. I had to replace one inductor which was open. I think I inadvertently nicked it when I was replacing the electrolytic caps. Over the years, I've collected a few books on TV repair which I found useful. They're shown here. The Odell's book was particularly helpful and relevant for a set of this vintage. This television is typical of models from the mid-1950s. The bakelite case is quite attractive. While restoring it, I brushed up my knowledge of television theory. I plan to put this old television on display in my retro basement rec room, along with other items I have there, including a jukebox and a couple of pinball machines. For authenticity, I'm hoping to buy a set of old rabbit ears, although I won't be able to receive on-air signals. I didn't yet do a full alignment of the unit. It seemed to be reasonably well aligned, but I may do that in the future. I have the necessary test equipment. It's quite impressive that this television could still receive television programs almost 60 years after it was built, until analog television was phased out just a couple of years ago. Finally, a piece of trivia. As a summer job, my mother worked in a TV factory assembly line around the time this set was manufactured. I don't know what company she worked for, but it was in the Toronto area, so it is just possible that she worked on this model, maybe even on this set. I hope you enjoyed this video on a piece of vintage electronics. Check out my other YouTube videos on vintage radio and test equipment.